How's it going, everyone? I'm Tom, and today I'm bringing you the future of router electronics, the Smoothieboard. In the course of the last 5 years since I took up 3D printing, pretty much every component of our printers changed and improved in some way. Hot ends are vastly different from what they used to be, the belts and linear guides are cheaper, more accurate and simpler to use properly. Controlling the printers changed from having a dedicated computer to using SD cards and LCD displays, networked Raspberry Pis, or even fully cloud-based solutions. However, one thing didn't change, and that's the very core, the brain of the printer, the microcontroller. Because, like the very first ones, the controllers that we typically use today are still based around the ancient and slow Atmel Atmega chips. Most boards are now using the equivalent of the Arduino Mega 2560, and that is the absolute end of the line for these processors. While most features were somehow adapted to run with the limited resources of the Atmega chips, many of them were stripped down or must even be artificially slowed down to run at all. Point in case, delta calculations. Right now it's a trade-off between precision and speed because this puny processor has no chance of accounting for the delta kinematics in real time. Or things like bigger color LCD screens, maybe even with a touch panel. No can do, not enough resources. And the thing is, even if you wanted to, there is no better or faster Atmega processor that we could simply upgrade to. And here's where the Smoothieboard comes in. Instead of using the ancient AVR architecture with an Atmega, which by the way is actually made for simple things like phones or gamepads, the Smoothieboard uses an ARM processor made by NXP, which is more in line with the kind of processing power you'd find in a 2D printer, in a network router, modem, Wi-Fi switch, or in the current generation of MakerBots, which do have things like a color screen and wireless networking built in. The Cortex M3 processor on the Smoothieboard runs at a cool 120 MHz, up from just 16 on the Atmegas. It has more RAM, it has a better analog digital converter for more precise temperature readings, and per clock it has more processing power as well. So really it's just downright better. This is also the same architecture that is used on the new Arduino Due and is also quite similar to what is used in today's smartphones and tablets. It could even run Linux. Now, of course, being a vastly different architecture from the old Atmegas, firmwares that are optimized for AVR won't run on the Smoothieboard without some major modifications. That currently includes Marlin, Sprinter, Repetier, and pretty much any other firmware. So the guys behind the Smoothieboard have also developed Smoothieware, a firmware specifically made for the Smoothieboard. Now, I don't want to talk too much about the firmware as that is constantly evolving and not really a part of the board itself, but right now it's pretty much the only firmware that runs on the Smoothieboard. But that's not necessarily a bad thing. Of course, Smoothieware is fully open source just like the Smoothieboard itself, so it can be modified as much as you want, but as of right now it does pretty much anything you'd want it to anyways. Auto bed compensation is there, as is support for many different motion platforms, including stuff like SCARA arms. Then there's support for multiple hot ends, auto PID tuning and automated delta calibration, as well as look-ahead motion planning with similar features to Marlin, temperature control, ATX power supply control, and all the other basic features. Some less used functionality like the grid mode for back compensation are currently being implemented, so they're not there just yet, but will be very soon. But overall, I think there's very little reason to complain about the feature set of Smoothieware. Now, two more things on the topic of firmware and stuff. Of course, this is not Arduino based anymore, so you don't get to use the Arduino editor for compiling and uploading firmware. Instead, you simply run make and drop the finished binary file onto the SD card, and the Smoothieboard's firmware will automatically flash the new version. But unlike Marlin, where you constantly had to reflash the firmware when you updated certain settings, Smoothieware reads its entire configuration from a simple text file stored on the SD card. You can simply open that up in any text editor and modify any and all settings. Click save, power cycle the Smoothieboard, and you're done. So really, I think it's much easier than dealing with Marlin and the 3 or 4 different config files for different settings. And the only reason you'd actually reflash the firmware on the Smoothieboard at all is when you'd want a newer version. And for those, you can simply download the readily compiled binary and copy that onto the SD card. And 4 GB micro SD card comes with the board, and that has all sorts of documentation, source files, test parts, and example configurations already loaded onto it. By the way, you can access the SD card right through the Smoothieboard's USB connection like a card reader, and of course also use it to store and print G-code files. So a bit more about the Smoothieboard itself. Right next to the SD card socket is a full-size Ethernet jack, which is used for a very simple web interface and some other networking services. Other than that, the Smoothieboard is actually quite similar to any other well-built integrated wrap board. It has the usual array of inputs and outputs, including 6 end-stop and 4 thermistor inputs, 3 high-power MOSFET outputs for things like heated beds, 3 medium power outputs for fans, hot end heaters, laser diodes, LEDs or other things you'd want to power, and of course it has stepper drivers on board, which are Allegro A4982 chips in a slightly bigger package than what you'd find on the Pololo modules, and because of that and the fact that the thermal design of the board is actually top notch, these drivers can put out quite a bit more current than the tiny Pololo modules. On the topic of current, the Smoothieboard also has software controllable current settings for each stepper, which is so much better and more robust than those fiddly little potentiometers. The usual complaint about integrated drivers is that once you blow one, you have to trash the entire board, but that's not the case here, as the control pins are broken out onto a header next to each driver, which also allow you to connect beefier external motor drivers, since the Smoothieboard is also marketed towards general CNC applications and not just 3D printing. The power transistors are split up into 3 groups. One is always powered by the common supply rail, and for the other 2 you can choose if you want to power them from the same supply rail or from their own power inputs, and I think that is a really good design choice there, because when you are using a heated bed you are already using up all those 12 amps of current that these detachable green connectors can handle. This way you can split up the current over multiple connectors and stay within the 12 amp limit for each connector. Alternatively, you can get the board without any connectors soldered and use whatever ones fit your needs. The board has different solder pads for small and large connectors on all inputs and outputs, so your options are definitely not limited here. Right next to the high power input is a 5V input, and by default the Smoothieboard does not generate 5V on its own, but you can solder in, for example, an integrated buck mode converter if you want to run the Smoothieboard without a USB cable or any other external 5V supply. The microcontroller itself runs on 3.3V, and that is generated on board. The rest of the board is littered with expansion options, breaking out pretty much any spare pin of the microcontroller. Now, one more thing I want to mention is the Smoothie Wiki, which includes a ton of information about the board itself and the firmware. It can be somewhat confusing at times where, for example, in one spot it recommends using an Arduino based adapter if you want to use an LCD panel, and in another shows you a dead simple electrical adapter that allows you to use LCD controllers without involving any extra processing power. But overall, the wiki is an extremely helpful resource. I'd even go as far as to say that if you're just getting into 3D printing and all the things that go along with that, including firmware and stuff, the Smoothieboard is actually easier to use and configure than modern-based solutions. So, of course, there is that one huge elephant in the room, and that is price. And admittedly, it's not exactly a cheap board, but that was never the point of the Smoothieboard anyways. The configuration I have here, the 5XC with 5 stepper drivers, 3 high and 3 low power MOSFETs, and all the connectors included and soldered in, is about 165 money units. If you can live with fewer stepper drivers and MOSFET outputs, you can already get a 3-axis Smoothieboard 3X for 100 monies. Everything in between with 3, 4 or 5 stepper drivers and with or without connectors is also available, so you don't have to buy the 5-axis one if you only have a single extruded 3D printer. Of course, it's still much more expensive than a Chinese RAMS kit, but when you compare it to a decent brand name board like the Aztec boards or the genuine Ultimachine Rambo, it is actually very competitively priced for what you get. It is a high-end board and it is one of the best, if not the best option out there right now. The ARM processor kinda makes it really good, and while it's definitely not used to its full potential yet, there are many more things to come that would be impossible to do on any older AVR based platform. And even without the shiny processor, this would still be a really nice board. At this point, a big thank you to Arthur Wolf, one of the developers of the Smoothieboard, for providing this review unit. As always, there are links in the video's description to the Smoothieboard site, and to the European shop and the US reseller. So yeah, I do like the Smoothieboard quite a bit. Let me know in the comments below what you think about it and what your favorite board is at the moment. As always, thanks for watching. See you next week when I bring you more futuristic plastic stuff things.